Okay, so doing related we're doing related rates. An airplane is flying towards a radar station at a constant height of 6 kilometers above the ground. If the distance s between the airplane and the radar station is decreasing at a rate of 400 kilometers, so we're going to look at it like this. Let's see. Towards a radar station at a constant height 6 kilometers above the ground. So that's going to remain constant. And then if the distance s between the airplane and the radar station is decreasing at a rate 400 kilometers per hour, then when s is equal to 10, what is the horizontal speed of the plane? So if 6 is like basically no matter what, it's going to be 6 kilometers above the ground, right? And then it says that if s is between the airplane and the radar station, right? So that's going to be like a hypotenuse that you're dealing with. And it says it's decreasing at a rate of 400 kilometers per hour. So then, right at the get-go, the way I would go about this problem is I would set it up where you've got your, if I can draw a little better, there we go, where you have your 6 kilometers above the ground, and then you know you've got this hypotenuse s. This is your 6 kilometers above the ground. And it says that we know s prime. So we know that s prime is equal to 400 kilometers an hour. We know that, what's the other one? This was, what was the horizontal speed? We know that, what else do we know? We know that y is equal to 6. So let's go ahead and set up a few equations. What we're going to do is we're going to say that this is the horizontal distance x. We're going to say that we have x squared plus y squared is equal to s squared. And then we are going to put in 6 here, and we're going to put in 10 here. So x squared is equal to 10 squared minus 6 squared. That makes that x is equal to the square root of 10 squared minus 6 squared. So then that follows that x is going to be equal to 100 minus 36. That's going to be equal to the square root of 64, which is just equal to 8. So we know now that x is equal to 8. So, oh, awesome, yeah, Vegeta rocks. So then, anyway, so for the rest of this, let's go ahead and do that, but let's do the equation for our implicit differentiation over here. Squared, and let's do 2x x prime. At this point, this is just implicit differentiation, plus 2y y prime, and I'm going to set this to 2s s prime. Your 2's cancel, you get x prime plus y prime is equal to s prime. So we have x check, y check, s prime check. So that's boom, boom, boom. Wait, do we have x prime? We don't. But we do have x, and we do have y, and we got s prime and s. So then the good thing about that is we can find x. So these really aren't that bad. You just kind of vectorially look at these, and you're able to solve them pretty conveniently. And so we're looking for this x right here. So I'm going to say that x prime is equal to s times s prime. And that color's nasty. I need to switch that a little bit. I don't really like that one that much. Maybe y'all can see if I do this. Let's see. I'm OCD. So let's see here. I got issues, man. So s prime. No, it's terrible. I'm overdoing it. Gosh, just kidding. So let's see. Let's just keep it. Let's keep it wide, I guess, over here. So we're going to say that x prime is equal to s times s prime, and we're going to subtract y prime, and then divide by that x there. So I just reorganize that for x prime. So then that means we just got to plug and chug now at this point. Pretty straightforward stuff. So then x prime is equal to, what's that, 10? Yeah, 10 times 400 kilometers per hour minus 6 times, did we have y prime on this one? Oh! Oh! It's constant, right? So if y is not changing, right, then that would be 0 here, right? Okay, good. Now that makes that 0, and divide that by 8, and that's our answer. So that's going to be equal to 4,000 divided by 8. 8 times 5 is 40. 8 times 50, 400. So I guess that x prime is equal to 500. Alright guys, hope that helps. This is the method of related rates. I've used implicit differentiation. We came to the conclusion that in fact y prime was equal to 0 because y is constant. Okay. That's it.